I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this series, we are preparing students for the highest level of competitions globally. I'm going to take some questions from past competitive exam papers. We'll discuss them at length, and I hope many of my subscribers will benefit. Some of you can also contact me for learning directly. The idea is to have creative thinking to solve such questions. You can contact me on the email address given here, and we can have Zoom classes one on one to prepare for the toughest competitions. Hi, Amy. How are you doing?
Hi, sir. Yes, I'm doing well, thank you. How are you?
Very good. So, today, what do you want to do?
I was hoping if we could just kind of continue with some, those like exam questions that were kind of varied on various topics of our course, just to, keep the mind going about how to approach different questions. That would be really helpful.
That's great. Last time I remember you had three questions from three different topics, altogether three
Yes.
different topics. So let's see what you have for today. You can share your screen, and then from there we can go. You can share your screen.
Yeah. Let's see this one.
Okay. Can you please read this question? Pretty long now.
Yeah. All right. So a mass mkg of a substance decreases with time t years. The mass of the substance can be modeled by the equation m equals a b to the power of t, where a and b are constants. Part A, show that the graph of ln m against t is a straight line.
Okay. So that is simple. You take log both sides, correct? So when you take log both sides, you get ln m equals to ln of a b to the power of t. Is that okay? So we get ln m equals to, applying the properties, right? So you remember the product rule, right? We could write this as ln a plus ln b to the power of t. So this means ln m equals to ln a plus t times ln b. Is it okay?
Yep, the t comes down.
So this is equation of a straight line. We say what? The graph of ln m. So this is y. Do you see that? So let me write this as capital Y, right? And that is a constant, c, plus t is a variable, right? And ln b is the slope. So mt. Do you see that? Where m is equals to the slope ln b of this particular graph. ln b is a constant, right? So ln b is also a constant. So when you sketch this particular graph, what will you get? So let me just sketch it here.
Wait, because it's y equals mx plus c form, can you just say that's a straight line?
Correct. That's what I'm trying to say, right? Well, c is the constant, right? So this is c, right? And that is your y. This is your t, correct? The variable, correct? And the slope, rise over run, is m, which is ln b in this particular case, correct?
Yeah.
Slope is ln b. So that is how you could show that the natural log of m for any exponential equation, that is the way to do it, right? So we calculate the exponential equation using logs, right? You could do natural log or to the base 10 and get this. And this is also important from another chapter which you have is linearization.
Oh, right.
So that is a non-linear graph we're talking about. M equals to a b to the power of t is an exponential function, which is non-linear, right? But as soon as you take logarithms, it becomes a linear function. So when it becomes a linear function, interpretation is much easier.
Right.
So this is very helpful. So I'm just writing a comment here. Helpful for interpolation. Since you have a straight line, you can easily, work out what will the value be, correct? And even for approximation,
Yeah.
Yeah.
Is this the same topic where you could like extrapolate or interpolate?
Yes. So you have a chapter which is
yeah.
linearization.
That chapter didn't ring a bell, but when you said interpolation, I was like, oh yeah.
Or functions, right? Do you understand?
Yeah.
So for exponential functions, this is the technique.
Right.
Okay. So what else? The graph of L and M against T passes through the point 0, 3.91. It takes 5 years for the mass of the substance to decrease by half. Show that A is approximately 50. So we can use this equation and then put the values here. It says, let's put these values. Let me use a different thing. Okay. The graph of L and M against T passes through the point 0, 3.91. So let's say we have a point here. Okay, 0, 3.91 is the y-intercept, C, right? So at 0, that means C is 0. C is equals to 3.91, correct?
Yeah.
It takes 5 years for the mass of the substance to decrease by half. So if I have another point here, which is like time 5 years, right? Then the mass becomes m by 2. Is that okay?
Yeah.
Fine. Show that A is approximately 50. So we know the value of C, correct?
So you said ln A equals 3.91.
Correct.
So A must
ln
equal
A. Yeah. C is ln
e
A,
to the
right?
power of.
Yeah. So we now know that ln A
e to the power of
is 3.91, right? So A is E. Can you calculate 3.91?
Yeah. So it says 49.898. So 50 approximately.
So that is how you're going to do this, right? Show that A is approximately 50. So we got the value of A, and we also know that C, right? So C is ln2, correct? So the intercept of ln M is known to us. Now it says, find to 3 significant figures the value of B. So because of the half-life, we can now find the value of B, correct?
Yeah.
So
is it T ln B, which is the mx?
Yeah, we can use the original equation. We don't have to use this equation now.
Oh, okay.
So half-life means m equals to A, B to the power of T. So that is your basic equation, correct?
We found A though as approximately 50. So.
Yeah. And now we know that half-life is 5 years, correct?
What's M though?
Pardon? M can be M. So basically, if M is what? Okay, that's a good point. So let's say if T equals to 0, let's write again this equation. M equals to A, B to the power of T, right? So if I write T equals to 0, that means initial starting point, right?
M equals A.
So M equals to A. Do you see that? M equals to A. Which is A times, let me write T to the power of 0, and then I'll write A. It's absolutely clear, right?
Yeah.
So the value of A is 50. So we'll start with, do we need to write an approximate answer? Find to 3 significant figures. So I'll write 49.
Maybe 49 point, yeah. Don't want rounding issues.
Is that okay? Now, half-life means what? At T equals to 5, the mass is m divided by 2, right? Which is 49.898 divided by 2, correct?
Oh.
Simple as that. And it gets cancelled. So we don't really have to bother that much. A is 49.898, correct? They cancel. So it doesn't really matter much, right? So B to the power of 5. Is that okay?
Yeah.
That 49 thing cancels, correct? Whatever you write, 50 or 49. So now we have half here, B to the power of 5, correct? Take log. Again, you can take log ln, right? So ln of half is equals to 5 times ln of B, right? Or you can do 5th root. Wait, we can just do, so B is equals to fifth root of half. Is that clear to you?
Wait, so we're subbing all of this into the m equals ab to the power of t.
Yeah, yeah, yeah. And M is half of what it was. So M and M cancel. You get the idea.
Oh, yeah.
A is the initial mass.
Oh,
A is the initial mass, right? So A is M0, initial mass, correct?
yeah, so b to the power of 5 equals half. So b equals the fifth root. Okay, yeah.
Fifth root of half, correct.
So let me quickly do that. Fifth root of 0.5, 0.871 to 3SF. I think that's what this is.
So, Amy, before we get into this particular question, can you note down all the values of A, B, which we calculated, and M? M is 8, right? And then we'll continue with the solution, okay? So let me clear the screen. Okay, great. So can you please again read this question?
Yeah. So after 8 years, the substance is modified to increase its mass by 20 kg. The mass of the substance then decreases according to the model.
Correct. So we want to find this mass here, right? How will you find it? Tell me.
So it says after 8 years, the substance is supposed to increase. So we need to find the mass at 8 years using
M equals to AB to the power of T, right?
Yeah, using that formula. And we've already got all the values, so we can just.
What are the values? M equals to, what is the value of A we got?
So 49.898.
49.898. 898. Okay. And B value was?
0.871 to the power of 8.
8. Yeah, calculate.
16.5286.
Right. So that becomes the mass after 8 years when it was decaying, right? So mass was decaying, it came to this level. Now it says this is after 8 years, right? After 8 years, the substance is modified to increase its mass by 20 kg. So after 8 years, we added 20 kg to this. You get the idea?
Yeah.
So it becomes what? 36.5286, correct?
Yeah.
The mass of the substance then decreases by this formula, right? So now we can find the value of P. So that becomes the initial mass, right?
What, 36.52?
Yeah, this is M, right?
Oh, okay.
Modified. So now we need to find what P is. At this time, we have started a new series and we'll take T equals to 0, correct?
Oh.
So we have 36.5286 equals to P plus 40 e to the power of minus. What is this? What is this?
0.32.
0.
What doesn't matter because it will end up being 1.
E being 0, right?
Yeah.
Correct. So from here we can find the value of P. So what is the value of P?
36.52 minus 40. Minus 3.471.
No, that. Oh, okay. So you did, okay, you brought it this side. So that is 1, correct?
Yeah.
So P equals to 36.5286 minus 40, correct? And you get that value as minus?
Minus 3.471.
Okay. So that's what you get. So P is a constant with this value.
Yeah.
Find the value of P. So that is how you're going to do this particular question. Is that clear to you?
So, yeah. So the hard part I didn't really get was, so after we found the modified one, you have to start a new series. So make it T equals 0.
At this time, we added 20 kg. Do you see that plus 20? And then it starts decreasing. Then again, it starts decreasing. You see that part?
Oh, from there. I see. Yeah. I was trying to do it from the same one. So I was like, what's the time then? Because we don't know. It could be like anything. But because it's starting again.
Correct.
Yeah.
Starts again. So it's a very interesting question. I hope you get it. So this is what happens at 8 years, right? So that's how we are going to do it. Okay.
Let's check.
Yeah. We got some value, right? Very small. Yeah. I think it's same, right? 3.5. They write minus 353. So some calculation you have to check. I mean, You got 3, 4.
36.52. Oh, they didn't use the round. Oh, see, you know the value of A, no, the value of B, where it was to the fifth root of a half.
Yeah.
We did 0.871. You can't, they didn't do that. They did 8705.
Yeah, they use 4 decimal places. So you have to be careful, right? So because the rounding is very, so that's why we got an error here, very important. So this value, which we use 0.871, do not round to 3 significant figures. This is 3 significant figures, right?
Yeah.
So really use 4 decimal places, okay?
Yeah.
So note.
Fifth root.
Yeah, use, because if you want 3 significant correct figures, you have to use 4 decimal places.
That's true, yeah. So 0.87055.
Yeah, and that
anyway, the method was correct. So
that caused the error here, 3.5 and 3.4, right? Do you understand?
Yeah.
So that way is correct. Yeah. And they do write correct answer is what? What do they write? Correct answer 3.5 is acceptable, right?
Yeah.
So 3.47 is close, but in that case you could round this and write this as minus 3.5. Okay. Anyway, so the method was correct, and important learning here is that use the values to 4 decimal place to get the accurate answer. Clear?
It's because of part A, B, and C, because you found the values. You think those are the values, but they're not.
Correct.
Yeah. So minus 40. Yeah, I got it.
Yeah.
It's
so the square root of half, which they did, they use 4 decimal places. Do you see that? 0.8705. Which was rounded to 871, and we used 871, and that's why we got this error. Is that okay?
Oh, I see. Yeah.
Perfect. Otherwise, it was good. Anyway, that's good.
Exponential question. It's time in terms of like learn natural log, trying to get it to correlate with y equals mx plus c in terms of graphing. So yeah, that question. The main thing we learned from that one was so if they have like a question and they're saying they wanted it rounded to like 0.871, don't use that value later on, even though that was the value given for that. You have to use the full thing, otherwise you can get rounding error.
So when you round to 3 decimal places, use 4 decimal places for your calculations.
Always one more than what the answer is supposed to be. Yeah. And then the final question was in terms of like you said, the wave. The wave
the wave function.
Wave function, yeah. So using the rules of that one and then solving. But yeah, a lot of graphing.
If you have a spring, correct, and if you just pull it and it oscillates, we can give you this wave function, right?
Oh yeah.
So many other wave functions, any heartbeat or any other periodic function, whichever you have, depending on from where it starts, that gives you the phase shift. And it could be written as a sine or a cosine function, or cos x plus alpha, or r sine x plus alpha. It's one of the same. So that's called the wave function, which is you can graph and interpret many things from there. And even in that logarithmic example, you saw how we linearized the curve, exponential curve, and extrapolated the value. You see that?
Oh yeah.
So
many topics are really linking in. Yeah, it's really good.
So great. We'll end the class here. And I hope you learned a lot.
Thank you so much, sir. Thanks. I did. I learned so much.
Have a great
Thank you, sir. Bye. And you. Have a good one. Bye, sir.
Bye.